Today, we're talking about the silent watchers inside your AWS account, CloudWatch alarms. Now, these aren't just for pinging you when something breaks. Nope. They're the key to building a cloud that can actually heal itself, scale on its own, and even trim your bill, all automatically. So let's dive in and see how they really work.
So let me ask you this. Is your cloud actually watching itself, or are you stuck in that reactive loop, waiting for a customer to tell you something's wrong? Just imagine automatically catching high CPU, stopping servers that are just sitting there burning cache, and scaling up before a big traffic spike even hits. That's the kind of power we're talking about today.
All right, so here's the plan. We'll start with the big picture of automating your cloud. Then we'll meet the different types of alarms. After that, we'll get into the logic of how they decide to trigger, see what they can do once they're triggered, tackle the super tricky but important problem of missing data. And finally, I'll show you the easy way to set up your very first alarm.
Okay, let's jump right in. Automating your cloud. At its heart, this is all about a huge shift in how you think. It's about going from being a cloud fighter, always putting out emergencies, to being a cloud architect, someone who designs a system that can see trouble coming and handle it on its own.
And this really gets to the heart of it, right? It's about two main things. First, performance. CloudWatch is constantly looking at stuff like CPU usage. If it sees a spike that's sticking around, it can tell your auto-scaling group to launch more servers, handling that extra load before your users even notice a slowdown. And second, cost. It can also spot a server that's been doing nothing for hours and just automatically stop it. You stop paying for something you're not even using. It's all about building a smarter, more efficient system.
So how do we actually get this automated monitoring set up? Well, it all starts with understanding the two main players in this game. So let's meet the alarms.
On one side, you've got the metric alarm. Think of this one as your specialist. It has one single job and it does it really well. It watches one specific thing, like the CPU on one server. Then, on the other side, you have the composite alarm. This is your supervisor. It doesn't look at metrics directly. Instead, it watches your other alarms. It only goes off if a very specific mix of those alarms all go off together. And this is where composite alarms are an absolute game changer. They cut down on alarm noise. Think about it. A single metric spiking for a second might not be a real problem, right? Maybe your database CPU hits 90%, but your app's latency is totally fine. A composite alarm lets you build a smarter rule, like, hey, only bother me if the database CPU is high and the application latency is also getting bad. It filters out all those little blips so you only focus on the real problems.
So now that we know the players, let's pop the hood and see how this works. How does an alarm actually look at a constant stream of data and decide, okay, now's the time to trigger? Well, it all comes down to a few key settings that work together.
First up, you have the period. This is basically how often you're taking a snapshot of your data. If you set a period of, say, 60 seconds, CloudWatch takes all the raw CPU data from that minute and kind of squishes it down into one single number, like an average. That becomes one data point for your alarm to look at.
Next, there's evaluation periods. This just tells the alarm how many of those recent snapshots to look at. So if you set this to 5 and your period is 1 minute, the alarm is always making its decision based on the last 5 minutes of data. Simple as that.
And finally, the most important piece, data points to alarm. This is your trigger condition. It's the M in what we call the M out of N rule. You're basically telling the alarm, out of the last N data points I told you to watch, M of them have to be over the line before you actually sound the alarm. This is what stops a single random spike from waking you up at 3 a.m.
Okay, and this table just lays it all out perfectly. Our rule here is 3 out of 5, and our threshold is 80% CPU. So, minute 2, we get a breach, but the alarm stays cool, it's still okay. Minute 3, we dip back down. Then minutes 4 and 5, we get 2 more breaches. Now, at the end of minute 5, the alarm looks back. It counts 1, 2, 3 breaching data points within the last 5 minutes, and boom, it finally goes into the alarm state. See? No panic over one little spike.
Okay, so the alarm is triggered. Now what? Because, let's be honest, an alert that doesn't lead to a useful action is just noise. So let's look at what these alarms can actually do for us.
And the options here are really powerful. You can go the simple route and just have it send a notification to your email or a Slack channel, but the real magic, for sure, is in the automation. You can have the alarm directly stop or reboot a server that's acting up. You could even trigger a custom Lambda function to do something complex like, automatically archive some logs before you reboot a server. And of course, the most common one, you can trigger auto-scaling to add or remove servers based on what's happening right now.
Just a quick but really important note here. Remember our supervisor, the composite alarm? While it's awesome for sending those smarter notifications and cutting down noise, it can't directly do things like reboot an EC2 instance or trigger autoscaling. Those heavy lifting automation jobs, those are reserved for the specialists, the metric alarms.
All right, let's talk about something that is so easy to overlook, but man, it can cause some major headaches. And that's what to do when the data just isn't there.
Seriously, think about it for a second. What happens when a server just goes offline or the network connection drops? If your alarm is expecting a data point every minute, but one doesn't show up, what should it do? Should it assume everything's fine, or should it assume the worst has happened?
Well, you've basically got 4 choices. You can tell it to treat missing data as breaching, which is perfect for a critical health check. If it stops reporting, you assume it failed. You can treat it as not breaching, which works great for metrics that only report when there's an error. So no data means no errors. You can tell it to ignore the missing point and just keep its current state. Or you can use the default, which is missing, and that puts the alarm in the special insufficient data state.
So, the takeaway here is that context is everything. There is no one-size-fits-all answer. You have to pick the setting based on what that metric actually represents. And trust me, getting this right is the difference between a reliable monitoring system and one that either cries wolf all the time or worse, sleeps right through a disaster.
Okay, that was a lot of theory. Let's make this real. How do you get started without needing a PhD in monitoring best practices?
Well, the great news is you don't have to start from scratch. Not at all. AWS has already done a ton of the work for you by providing a whole set of recommended alarms based on what they see people commonly need. It's a massive head start.
And using them is super easy. You just go into the CloudWatch console, head over to All Metrics, and click on the Alarm Recommendations filter. Then you just pick a service, like EC2, and it shows you a list of smart alarms you should probably create. You click one, and it fills in all the settings for you. The threshold, the period, the whole shebang. It is, without a doubt, the fastest way to level up your monitoring.
So that's the lowdown on CloudWatch alarms. You now have the building blocks to turn your cloud from just a bunch of passive resources into an intelligent system that can actually manage itself. And that really just leaves one question to think about. What critical event, what money-saving opportunity, or what performance bottleneck is your next alarm going to catch for you?